Hello friends, welcome to EduCeption. In this video I am going to teach you calorimetry. But before starting, make sure that you have subscribed to EduCeption, and if you do like this video, share it to the friends and do hit the thumbs up. So, what is calorimetry? Calorimetry is the science in which we measure the amount of heat gained or heat lost by the body. But it depends upon several parameters. We are going to study it in detail. The first thing that you should know before studying calorimetry is the heat. Now, what is heat? Heat is a total internal energy possessed by a body. Now you know all bodies or all matters are made up of molecules, and they have intermolecular force of attraction due to which they possess some potential energy. Also, all the molecules are in a state of random motion due to which they possess some kinetic energy. And what is internal energy? The summation of both the potential energy and the kinetic energy. And this internal energy is known as the heat energy. So friend, that was all about the molecular concept of heat. But how does heat transfer occurs? It occurs in a similar fashion as stated by law of conservation of energy. What is it? Energy can neither be created nor be destroyed. It only changes from one form to another. Similarly, heat gets transferred from a hotter body to a colder body. Now, as all other forms of energy, heat too has SI unit as joule, which is denoted by J. Generally, we do not use joule, we use calorie, which is denoted by Cal. They have a relation between them, and that is 1 calorie equals 4.18 joule or 4.2 joule. Now, there is a definition of 1 calorie. What is it? 1 calorie is defined as the amount of heat energy required to raise 1 gram of water through 14.5 degrees centigrade to 15.5 degrees centigrade. Note the temperature, right? Now, if you have to define 1 kilocalorie, that mass 1 gram will be changed to 1 kilogram. That is 1 kilocalorie will be the amount of heat energy required to raise the temperature of 1 kilogram of water from 14.5 to 15.5 degrees centigrade. Now let me give you the concept of temperature. What is the temperature? Temperature is defined as the degree of hotness or coldness. I told you that heat gets transferred from a hotter body to a colder body. So how are you going to determine which body is hotter with respect to other? That is determined by the fact of by the concept of temperature. What is it? The degree of hotness or coldness, right? Means the body at a high temperature is hotter with respect to other, and its unit is Kelvin, which is denoted by the symbol K. It too has a different system, that is degree centigrade, and the relation between them is Kelvin equals temperature in degree centigrade plus 273. Now, there is a term related to the Kelvin scale, that is 0 Kelvin, which is called as the absolute scale of temperature, because at that temperature all the molecular motion ceases and it is equal to minus 273.15 degree centigrade. Having got a brief knowledge about heat transfer, I will tell you the factors on which the heat transfer or the quantity of heat energy depends. It depends on several factors, out of which the first one is mass. Now, when our mother cooks food, if the family is small, the amount of heat energy required to cook the food will be small. For example, say if you have a small family of 4 persons, then amount of heat energy required to cook the food for those 4 persons will definitely be smaller than for a family of 10 persons, right? So, quantity of heat energy required directly depends on the mass of the body. Higher the mass of the body, higher is the amount of heat energy required. Similar is with change in temperature. Say you have 2 bodies, right? For which you want to give different rise of temperature. For example, say you have 1 liter of water which you want to rise by 10 degrees centigrade, and another 1 liter which you want to rise by 20 degrees centigrade. So the amount of water for which you want to rise by 20 degrees centigrade will absolutely be greater than the 10 degrees centigrade, right? That is, amount of heat energy required directly depends on change in temperature. Combining these two equations, we will get quantity of heat energy is directly proportional to mass and change in temperature. To remove this proportionality symbol, we have Q equals Cm delta T. What is this C? This is specific heat capacity. Now let us study specific heat capacity in detail. So first of all, definition. What is specific heat capacity? Specific heat capacity is the amount of heat energy required to raise the temperature of unit mass of a substance by 1 degree centigrade or 1 Kelvin. Thus, a similar concept is heat capacity. What is heat capacity? Heat capacity is the amount of heat energy required for raising the temperature of a substance by 1 degree centigrade or 1 Kelvin. Let me give the equation of them. They are it is denoted by C equals Q by M delta T, and this is denoted by C dash, which equals Q by delta T. Are you getting the difference? C equals Q by M delta T, C dash equals Q by delta T. That is, specific heat capacity is the amount of heat energy required to raise the temperature of unit mass of a substance by 1 degree centigrade or 1 Kelvin. Whereas heat capacity is the amount of heat energy required to raise the temperature of the whole substance by 1 degree centigrade or 1 Kelvin. Let me give you an example. Say you are buying a pack of 10 pencils, right? So the cost of one pencil is the similar like specific heat capacity, right? Cost of one pencil. Whereas the cost of the whole set is the heat capacity. It depends upon the total number of pencils, whereas it doesn't depend, right? The cost of one pencil is fixed, whereas the cost of the whole pack depends upon the number of pencils you are buying, right? 10 pencils or 20 pencil sets, right? So similar is the concept. It depends upon the mass of the body, but it doesn't depend upon the mass of the body. Now let us study some basic concept of specific heat capacity. Different bodies have different specific heat capacity. That is, they take up different amount of heat energy to give same rise in temperature. The body which has high specific heat capacity is a bad conductor, whereas the body which has low specific heat capacity is a good conductor. Water unusually has a high specific heat capacity of 4200 joule per kilogram per Kelvin, and it explains the natural phenomena as water is used as an effective coolant. Water when passed through different heated parts of machine, it extracts heat from them without giving much rise in its temperature. In a similar manner, it is used as a heat reservoir in cold countries. What happens when in cold countries the temperature of the surrounding falls down? The water gives much heat to the bottles which is kept in it and prevents them from freezing. In a similar manner, we have some examples of heat capacity. The base of the cooking pan is made thicker. By doing so, the material is increased, and thus the amount of heat energy is increased. When the amount of heat energy is increased, the cooking pan can supply much heat to its content, and thus the food is cooked properly. Whereas in the same case, we have base of the iron pan is made thick. In a similar manner, the iron need much more heat, and thus it can function more properly. Let us move on to the final section of the video. We have a calorimeter drawn over here. So it's a calorimeter. Calorimeter is a cylindrical vessel which is used to measure the amount of heat gained or lost by a body when it is mixed with other body. And it is made up of copper, because copper is the good conductor of heat, so it can acquire heat from its content. And the second thing is, it has low specific heat capacity, right? And finally, we have principle of calorimetry. What is it? If no heat is exchanged with the surrounding, then heat gained, who will gain the heat? Cold body. Heat gained by the cold body equals heat lost or ejected by the hot body. This is it for this video. In the next video, we are going to solve problems based on the principle of calorimetry and other. Till then, stay tuned.